Hello everyone. Today we are going to see one of the very important concept of number system, that is called unit digit. We all have studied this unit digit in our school time. Okay, so the question will be same, but the level of difficulty will be very high in competitive examination. So suppose that if I'll ask you question like what will be the unit digit of 1 4 5 7? Okay, 1457, what is the unit digit of this number? You can easily tell me, the sir, the unit digit of this 1457 is 7, because we all know that unit digit means the first digit from right hand side. So in 1457 the first digit is 7 from right hand side, so the unit digit of this 1457 is 7. But they in competitive examination also they will ask you the same question, but they will twist the question, like they will give you like this: 1457 to the power 71. Suppose that this type of question they will ask you, 1457 to the power 71, what will be the unit digit of this number? Now without calculator, without computer, it is almost impossible to calculate this 1457 to the power 71. Okay, and in standard competitive examination, as we all know, that we have to solve questions within a minute. So to calculate this 1457 to the power 71 without calculator, without computer, it's impossible. Okay, and without calculating this 1457 to the power 71, we cannot find out that what will be the unit digit of this number. Okay, so to find out the unit digit of this number, we have to apply some other method to find the unit digit of this type of huge number within a minute. So what will be the method, how to solve this type of huge numbers, how to find out the unit digit, we will see in this video. Okay, so in my next slide, this is a cyclicity of number. So before solving any unit digit question, we have to understand the concept of cyclicity of a number. Okay, so what is the cyclicity of a number? I am explaining you here. See, here is one table I have written in my slide. So suppose that the number is 2. We all know 2 to the power 1 is equal to 2, and the unit digit of this number is 2 only. Correct? Now if I will do 2 square, it will become 4. 2 to the power 3, it will be 8. 2 to the power 4, it will be 16. 2 to the power 5 is equal to 32. Once again, in power 5 I am getting 32, that means 2 in unit digit. Yes or no? Getting it? That means for 2 in power 5, the cycle is repeating. The unit digit is once again coming as 2. That means the cyclicity of 2 is 4. After power 4 in power 5, the unit digit is repeating here. Cyclicity is repeating here. Understood everyone? So once again I'm repeating this concept. Once again, if I will take the number 3. Now 3 to the power 1 is equal to 3. Unit digit is 3. Correct? Now square will be 9, cube will be 27, 3 to the power 4 is equal to 81, and 3 to the power 5 is equal to 243. Once again, in this 243, what is the unit digit? It is clearly showing here that unit digit is 3. Okay, that means for 3 also the cycle is repeating after power 4. That means in power 5 the unit digit once again it's coming as 3. Correct? So the cyclicity of 3 will be 4. After power 4 in power 5, cyclicity is repeating. Okay, now if we'll go for 4, then 4 to the power 1 is equal to 4. Unit digit is 4. Square will be 16. Cube will be 64. And in this 64, here the unit digit is 4. Correct? That means here for 4, the cyclicity is repeating in power 3 only. So the cyclicity of 4 will be 2. Why 2? Because after power 2 in power 3, cycle is repeating. Understood? For 5 it will be 5 to the power 1, 5. 5 square will be 25. So cycle is repeating here in power 2 only, so the cyclicity of 5 will be 1. For 6, the same thing as 1. For 7, if we will go like this, we will get the cyclicity will be 4. For 8, it will be 4 once again, and for 9, it will be 2. So we don't need to write these things in examination. The only thing that we want to solve our unit digit problem is the cyclicity of the number, that is here 442114442, and it is easy to remember. See, it will start from number 2. If I'll talk about 2, the cyclicity is 4. 3 will be 4, 4 it will be 2, and then for 5 and 6, 1 and 1. For 7, once again 4 4 2. So 4 4 2, correct, and in between 1 and 1 is there for 5 and 6, okay, and then once again 4 4 2. So it's easy to remember 4 4 2, 1 and 1, and once again 4 4 2. Okay, if this is clear, how to find out the cyclicity of number, I have explained here, that how this the cyclicity of 2 is become 4, the cyclicity of 3 is become 4, 4 becomes 2, correct. So but you don't need to mug up all these things. We have to get this cyclicity of the given number to get the answer of the given question. Okay, now next one, if I'll go in my next slide, there are some key points. Before solving any unit digit problem, we should remember these key points. So the first point is, if remainder is 0 and last digit of a number is 2, 4, 6, 8, then the unit digit will be always 6. I will explain you all these 3 points, but for now just keep it in mind. Okay, second point is, if remainder is 0 and last digit of a number is 3, 7, 9, then the unit digit will be always 1. Okay, now the last one, if last digit of a number is 5, then the unit digit will be always 5. See, 5 to the power square, it will be 25. Once again I am getting unit digit as 5 only in 25, yes or no. 5 to the power 3, 125, correct. So once again I am getting this 5 as unit digit. So 5 to the power any number will give us 5 in unit place. Okay, so these are the 3 key points. I will explain you all these 3 points once again when we will solve the problem. So quickly we'll go for first problem. Here the problem was 1457 to the power 71. Okay, that I have taken this example in my previous slides. Okay, so 1457 to the power 71, huge number it is. We have to find out the unit digit of this number. How to find out? With the help of cyclicity of number, I will explain you step by step. Just try to understand this. First step, what we have to do? In first step, we have to find out the last digit of the given number. So what is the last digit of the here in 1457? It is clearly visible here, it is 7 only, correct. So 7 is here. What is the cyclicity of 7? We all know the cyclicity of 7 is 4. If I will show you here in this table, the cyclicity of 7 is 4, yes or no, correct. Now, so cyclicity of 7 is 4. Now we have the cyclicity of 7 as 4. Now what we have to do? We have to divide this power by 4. We have to divide this power by 4. That means whatever the question they will ask in competitive examination for unit digit, we have to divide the power by the cyclicity of the last digit. Okay, so last digit was 7 here, and the cyclicity of 7 is 4, and so we have to divide this 71 by 4. First step is this one. Okay, now when we will divide this 71 by 4, we don't need to consider this part, no. Okay, we have to consider the remainder. So what is the remainder here? If we will divide 71 by 4, we all know the remainder will be 3 only, correct. Now remainder is 3. After this, the second and last step is what we have to do. One method or formula you can tell, that is called L to the power R. Okay, what is L? L is last digit, L is last digit, and R is remainder. R is remainder. Okay, okay. So last digit is in our question is 7, okay, and remainder is 3. Yes or no? So 7 to the power 3 will gives us 343. Correct? Now 343, what is the unit digit? Unit digit is 3. So our answer will be 3 only. That's it. Only that much, that two step you have to do in examination, and you can solve any question of unit digit within a minute. There is no doubt about it. Quickly, if we'll go for second example. Now see, here the question is 264 to the power 102 plus 264 to the power 103. Once again, what is our first step? What is our first step? Our first step is we have to find out the last digit of a number. So we will divide this. Two numbers is given, 264 to the power 102 and another one is 264 to the power 103. So if we'll talk about this number 264, what is the unit digit, what is the last digit of 264? It is 4 here, correct? And what is the cyclicity of 4? We all know the cyclicity of 4 is 2. If I'll show you in that table, see, the cyclicity of 4 is 2. Yes or no? Because in power 3 it is we are getting 64. Once again I am getting this 4 in unit place. So after power 2, the cycle is repeating here for 4. That's why the cyclicity of 4 is 2. Correct? Now, so for this question, the cyclicity of the last digit is 2. Correct? Now if we divide the power, next step, divide the power by 2, what will be the remainder? Remainder will be 0. Yes or no? Correct? And in this case, we have to go for our key point. What is our key point? See here. If remainder is 0, yes or no? If remainder is 0, so in this case we cannot apply the method L to the power R, last digit to the power remainder, correct? So here if the remainder is 0 and the last digit of a number is 2, 4, 6, 8, correct? In second point, if remainder is 0 and last digit of a number is 3, 7, 9. So in our question, what is the last digit here? Last digit is 4, correct? So if remainder is 0 and last digit of a number is 2, 4, 6, 8. So 4 in our question it is 4, correct? Then the unit digit will be always 6. You have to remember this one for direct calculation, okay? If remainder is 0 and last digit of a number is 2, 4, 6, 8, then the unit digit will be always 6. So directly we will put here as 6. What will be the unit digit of 264 to the power 102? It will be 6 only. Correct? Now plus 264 to the power 103. Once again the last digit is 4, correct? And the cyclicity of 4 is 2. If we will divide this 103 by 2, what we will get in remainder? In remainder we will get 1. Correct? Now here we have to apply the method of L to the power R. Correct? L to the power R. So what is L here? Last digit is 4 and remainder is 1. So 4 to the power 1 will gives us 4 only. So 6 plus 4 is equal to 10. What will be the unit digit of this 10? 0 only. So what will be our answer? 0. That's it. What will be the unit digit of this 264 to the power 102 plus 264 to the power 103? It is 0. Understood everyone? Last example if I will take, find the unit digit of 3547 to the power 153 into 251 to the power 72. So first digit is 3547 to the power 153. Okay. So what is our first step? Last digit is 7. What is the cyclicity of 7? We all know the cyclicity of 7 is 4. Correct? Next step, we have to divide this power. What is the power? 153 by 4, correct? So 153 divided by 4 if we will do, what we will get in remainder? In remainder we will get 1 only, correct? So in remainder we found 1. So next step is L to the power R. That means L to the power R, that means last digit is 7, remainder is 1. So 7 to the power 1 will give us 7 only, correct? Into 251 to the power 72. Now see, 1 to the power any number, what will be the unit digit? 1 to the power 1, 1, 1 square, 1, 1 to the power 3, 1, 1 to the power 4, 1, 1 to the power 900, 1, 1 to the power 182. It will be also 1 only, correct? So 251 here it is given, and unit digit is 1. It's clearly visible here. To the power any number, what will be the unit digit? Unit digit will be always 1. So 7 into 1 will gives us 7 only. So what will be the unit digit of this product? 3547 to the power 153 into 251 to the power 72 is 7 only. That will be the answer of this question. The unit digit of this product will be 7. I hope you people understood this concept of unit digit. In this way you can solve any unit digit problem within a minute in competitive examination, that's for sure. Okay, so if you like this video, this concept, this method, then please like us on our social networking sites. Okay, that's it. Thank you very much.